Good morning, all. Great to have you joining us here from this webinar. My name's Belinda Kay. I'm with Ag Communicators, and I'm also part of the Disease Management Extension Network, which is a GRDC investment. Today, we are joining you on our Disease Management for Canola webinar, where we'll be exploring practical advice for the 2026 season. And we're really pleased that you can all join us. As far as the day goes, we've got a jam-packed agenda, and I'd like to firstly thank you all for popping in your questions in the registration process. We've had around 60 questions come through from over 220 participants, and so we're thrilled to be addressing these today. You can see we've got a really great lineup of speakers, and today we're going to be exploring the main disease risks in canola, the seasonal outlook and implications for disease development. We'll look at the integrated disease management tactics and fungicide resistance considerations. We've got a great lineup of speakers as well. So I'd like to introduce our speakers here today, and I'll get them to give you a wave as they come on. So we've got a canola blackleg update with Dr. Steve Marcroft from Marcroft Grains Pathology and Dr. Angela Van de Wouw from University of Melbourne. We'll then move into turnip yellow virus and green peach aphid update with Dr. Nicole Thompson, Dr. Maarten van Helden and Dr. Narelle Nancarrow, and we'll then move into some questions and answers. So I'd like to do a quick introduction of our speakers to begin with. We have kept their bios short. You can find out more about them afterwards. We'll be sending some links around, but we thought it more important to get more of your questions answered than have lengthy bios. But let me just give you some insights into our speakers. So Dr. Angela Van de Wouw is with the University of Melbourne and Marcroft Grains Pathology. Ange is a plant pathologist with the university and also Marcroft Grains. Her research focuses on canola diseases, fungicide resistance, and practical disease management strategies for Australian growers. Dr. Steve Marcroft is a plant pathologist and director of Marcroft Grains Pathology. He's internationally recognised for his work on blackleg disease in canola and developing practical disease management strategies for growers. Dr. Nicole Thompson is Program Leader of Plant Health and Diagnostics at SARDI. She is a plant pathologist specialising in plant virology, disease diagnostics and biosecurity with a focus on protecting SA's plant industries. Dr. Maarten van Helden is an entomologist and sub-program leader for agroecology and integrated pest management at SARDI. His research focuses on integrated pest management and insect pests affecting Australian grain production. Dr. Narelle Nancarrow is with Agriculture Victoria. Narelle is a molecular epidemiologist with Agriculture Victoria, whose research focuses on viruses affecting cereal, canola, and pulse crops and improving disease management through a better understanding of virus epidemiology. I'm also pleased to welcome here today Dr. Kurt Lindbeck, who's with New South Wales DPIRD. While Kurt is not giving a formal presentation, he's online here and will give us a quick update on what's happening with Sclerotinia, which we're really thrilled about. Kurt is actually a plant pathologist with the New South Wales Department of Primary Industries and Regional Development, based at the Wagga Wagga Agricultural Institute. His research focuses on disease management in pulse and oilseed crops, particularly blackleg and Sclerotinia, and he's developing practical tools to help growers manage disease risk. So as you can see, we've got an outstanding lineup joining you today, and we have worked to include as many of your questions in our content as we go. Okay, a few bits of housekeeping for you all. We do have a large number of people joining us today, and so we ask that you please remain on mute and your cameras will remain off because we are recording. We've had some people not being able to attend today, and so we will be sharing this recording afterwards, and we'll send you a link in case you'd like to watch a follow-up. If you would like to ask questions as we go, please type these directly into the Q&A box at the bottom of your screen, and we will reply to these either directly via the box or we'll ask the panel speakers at the end. Now, just a quick note, you do have a chat at the bottom of your screen, but we would like you to click on the Q&A box and use that one as preference. Thank you. And if you have any issues with audio, we have got all the speakers practicing beforehand and we can hear them loud and clear. But just in case, a good thing to do is to log out and try logging back in again, and that usually resets. So fingers crossed, we're all smooth sailing from here. Okay, well, I think we're about ready to get into it. But first, I would just like to firstly give a shout out to our team. We're part of the Disease Management Extension Network. You can see us all down here. We're a national project, which is one of GRDC's major investments, and it brings together the disease management network across all of Australia. Our goal is to increase the adoption of fungicide resistance and disease management strategies to reduce the emergence and impact of fungicide resistance and key diseases. You can see all of our project partners across Australia up the top with their logos. And I guess from our end, being part of this network is really exciting because it means we can deliver really agile webinars at the right point in the season. And before we launch formally into our speakers, I would also just like to acknowledge the Kaurna people on the lands where I'm sitting today. And I'd also like to pay my respects to their elders, past and present, and acknowledge the presence of Aboriginal and Torres Strait Islands people who are joining us here today. So without further ado, Bridget, I'll hand over your sharing the screen and we will pass directly to Steve and Ange to kick things off. Thanks again for joining us.
Okay, great. Thanks, Belinda. So yeah, we'll get straight into it. So 2026 is obviously a bit of a year that's out of the box for disease control or disease severity. This is certainly a couple of weeks ago when I started seeing the disease really come in thick. It really reminded me of the year 2016, which was our really last big year disease. So I'm going to start straight away saying what has made 2026 different. So why have we seen this level of disease in these photos here, which is very, very abnormal for this time of the year or any time of the year. So the first, I guess, smoking gun is the temperature that we've experienced this year. I know everyone's been talking about how warm it is and how quickly the crops have been growing and developing. These are just some screenshots I stole off Dale Gray's seasonal climate update, and these were for May. I think the June ones will come out very soon. I think they're very similar, but the reality is, just as a quick note, that most of Victoria in May was, as you can see, a decile 10 for temperature. And then if we look at, for the maximum temperatures, look at the minimums, we're actually decile 10 or hottest on record. So it's a really, really warm winter that we're currently having. And fungal diseases, like all fungi, really enjoy warm weather. That's, why we keep our food in the fridge, etc. So the first, I guess, indication is that we've got really warm conditions. The second one is rainfall, which we're obviously all aware of. But the thing I want you to point out with rainfall is not just the amount of rainfall, it's when the rainfall falls and how often it falls. It's really important. So if you look at the cumulative rainfall here for Horsham, you can see it was pretty much since February we've been wet and we've remained wet since that time. And that's actually really important because Blackleg is a sexually reproducing disease. It undergoes sexual reproduction on the stubble. So basically it has to mate within the stubble, the mycelium needs to grow, and then it needs to produce these fruiting bodies, which then are triggered to reduce spores with each rainfall event. But this all takes time. And normally we don't see major spore release occurring until June. And this year, because of that extreme rainfall, you can see the average is down here. This has happened a lot earlier than normal. And it's meant that as our crops are in that vegetative stage, the stubble is completely primed and producing maximum spores every time we get a rainfall event. And then the other part of this is the actual rainfall totals itself. So May and June, we've been average to above average, but it's not actually anything that unusual for what we might see in a wetter year. But this is really interesting here. This is the number of rainfall days that we've had here at Longerong and Horsham over the last month. And you can see here during June, we only had 5 days without rainfall. So we've had warm conditions, we've had early onset of rain and constant rain, and now during our actual infection period, we've had constant rainfall on nearly every day of June. And this is what it's resulted in. So this is a photo I took on Thursday last week. So we hadn't had any rain for 3 days at this point. And this was in the afternoon. And just look at that leaf wetness. It is amazing. Like, you walk into a crops now and you get absolutely soaked. And it's this leaf wetness which drives the disease cycle. So in a normal year, we'll have rainfall events, and then we have dry periods, and we have rainfall events. And those dry periods really slow the disease progression up. But there is nothing slowing disease progression in 2016, and which is why we've suddenly seen in the past 2 weeks this massive explosion of disease. And we've already got crops hitting first flower, and when you see this and you're a pathologist, you think, I'm just going to go and buy some shares in fungicide, because these plants are just absolutely saturated, as you can see. And like normally with our flowering window, you know, if it's coming into spring, we dry out between rainfall events. But if you've got crops flowering early at the moment, there's no drying out, and it's just disease cycle after disease cycle. So that's all resulted in. These are photos I've taken this week and last week. We've already got crown canker in some of our seedlings. There's leaf lesion development on leaves, which I haven't probably ever seen before this time of year, where these crops here, you could spot the blackleg driving past them in the car. It was amazing. You think that someone's gone, you know, had some herbicide issue, and you get there and it's actually all blackleg that's turning up. So this was actually northeast Victoria. We've got older leaves which are completely colonised and destroyed, and we've also got crops which are coming into flower already with upper canopy symptoms. This was the end of June. So what does this all mean? So just going back one step, and we'll talk about what we should or shouldn't be doing about it. So blackleg disease life cycle, as we said, all the spores which we need to contend with are really originating from last year's canola stubble. So it's higher rainfall regions, it's the canola wheat rotations where there's a lot of canola stubble in the system which drive it. These spores land on our seedlings, on our cotyledons, and our leaves, and then they grow within the vascular tissue down to the crown, which causes the canker at the end of the year. The important thing with this stage of the disease is it's the seedling infection which results in the crown canker, which is why our seed dressings work so well, our seed treatments, and why when we normally put a foliar fungicide on, it's that 4 to 6 leaf stage. It's all about protecting that seedling. One of the interesting things I think with blackleg is most people with fungicides like to talk about it being protective because, for instance, like a rust, you're trying to protect that leaf area. With blackleg, the disease cycle is a little bit different in that the spore itself has to cause a necrosis. So it kills the plant tissue. It then colonizes that dead plant tissue and uses that as an energy source before it then goes into the vascular tissue to cause the damage. So the leaf lesions themselves aren't really actually causing us a lot of yield loss in a normal year. It's the systemic stage of the disease. So I actually think we actually get quite a bit of curative effect with our fungicides, because if we can kill the disease at this stage with a fungicide before it actually goes into the vascular stage, there's a benefit there. So there is, I think Angela's going to talk about the fungicides later, but just to sort of remind you that there is some benefit in curative as well as protective. When we get to our upper canopy, so our plants are now flowering and getting infected, exactly the same process occurs. We get the infection, it then grows down within the peduncle or the branches, and then gets inside the upper stems and branches and causes upper canopy infection. The big thing with upper canopy is it's about when this infection occurs. So much like the seedling disease, you have to get the disease as a seedling to cause the crown canker at the end of the year. It's the same with the flowering. You need the early flowers to be infected so the disease has got enough time to get into the vascular tissue and cause the yield loss. If we get infection occurring in the spring, it's just too late. It can still occur, it can show the same symptoms, but you don't get any yield loss. It's the early infections which cause the yield loss. So, what's happening in 2026? Now, the first thing we're going to look at is our genetics. So on the side here, I've got a photo of our cultivar, which is a Group H cultivar, and is has an effective major gene. So an effective major gene is a gene-for-gene interaction. The plant recognises it's being attacked, turns on its defence mechanism and stops the disease. And these plants are still showing complete immunity this year, even under that extreme disease pressure. So if your cultivar has effective major gene, they're standing up really well, and you won't need to put a fungicide on them. Now, this data here is from our Blackleg monitoring site. So this is just an average of all our Victorian sites at this stage. This is where we grow our resistant cultivars side by side. So this is from 8 sites across Victoria. And this is the amount of leaf lesions that we counted over 20 plants. And you can see here that the group S, D, and F are all actually doing a really good job at reducing the amount of disease, and that group H is just that one step ahead. I mean, this may change over the next few years when these are more widely grown, but at the moment, all those groups are actually standing up really well. So that's fantastic. You can see here our BCs. So we've got the BCs here with high quantitative resistance, low quantitative resistance, and one with Saltro. And you can see they're really showing no effect on reducing leaf lesions. You might be surprised here that the Saltro has got so many leaf lesions, but that's totally expected because that Saltro is really only controlling the disease in the cotyledons, the first couple of leaves, and the data we're collecting now is more like at the 8-leaf growth stage. So this is what we're seeing. So these 2 photos here on the left of the screen are the typical disease that I would expect to see on canola at this time of year. So we're getting some leaf lesions coming in. There's not too bad. And then in 2016, at the same growth stage, this is the type of disease that we're seeing. Total leaf colonisation, leaves just collapsing under the pressure. You can see here, this is a real warning for me. The midrib, the veins getting colonised. And then on the photo on the right, the whole PDL collapsing as the disease is progressing down to the crown. So these are real warning signs for me that there's going to be significant yield loss. So the question we have now, we know that our effective major genes are still working. So for all of you guys out there who are seeing massive amounts of leaf lesions, that means you don't have effective major genes, because if you did have effective major genes, you won't be seeing leaf lesions. So if you're seeing leaf lesions, it means you don't have an effective major gene. So you are now totally reliant on quantitative resistance. And quantitative resistance is fantastic. It's very, very effective. But the thing we do know about quantitative resistance is that you'll see different amount of disease depending on the disease pressure of the year. So if we just look at our MRs here, which most of you will be growing, under a normal disease pressure, they're fantastic. You don't need a fungicide. But as you increase that disease pressure, they will start to take a lot of disease and they will really appreciate a fungicide and give you an economic response. So basically our MR cultivars are really showing this year is the year they're going to get a lot of disease and they're going to need a fungicide. The other important thing to note with quantitative resistance, and this is really strong this year, is that, as we'd said before, Blackleg is a population. So it adapts to our quantitative resistance and to our fungicides very quickly. And the more you grow a cultivar, the more you will select isolates to attack that cultivar, and you will skew your Blackleg population to actually be adapted to and attack the cultivar that you're growing. So what we see, if you've been growing the same type of genetics for 3, 4, 5 years, you will start to adapt or change or skew that Blackleg population to overcome your resistance. And the best example, the easiest one for us, is that bonito effect. We saw when bonito was first released in 2014, it was an MR, and it stayed as an MR for a number of years. But because it was growing so widely over such a large scale, we saw its resistance ratings really collapse at the end of its life there. And it reacted very differently to what it was when it was first released. And that's not the cultivar changing, that's just the Blackleg populations changing against it. We've got an investment currently with GRDC where we're actually trying to quantify how we do this, and we've come up with a technique to actually measure this. So last year we screened 30 different stubbles that agronomists sent in, and you can see here about 40% of them we classified as being broken or overcome. So we're seeing a strong selection towards common cultivars. And you might say, well, why do we continue to grow these cultivars? It's because they're the highest yielding ones. You're getting the high yielding cultivar with the right herbicide technology, etc., and that's what people are growing. And it works because as they lose resistance, you can protect them with a fungicide. But what we see is in years like this with that really high disease pressure, that's when these problems really come to the front and get expressed. So, current decision, do I spray or not? Sorry, yes. So, right now, we have perfect conditions for blackleg, that's obvious, but we also have perfect conditions for plant growth. And that's actually a really key factor in our favour. So when plants are very small and it's cold and wet and they're not growing actively, the disease can progress faster than the plant, and that's where we see the crown canker. So the plants were at the 2-leaf stage in June and it's really cold and the disease gets on top of them, that's when we see massive issues. This year, our plants are actually growing really quickly, so that's massively actually in our favour. So I just wanted to point that out. So we've got good conditions for blackleg, good conditions for plant growth. We're seeing in many of our cultivars this genetic erosion of resistance. So the cultivars may have a lower blackleg rating than what's advertised on your farm. So basically with all that, I'm saying 2026 is the year that we need to use our fungicides. So most years I try and talk agronomists out of using fungicides. This year I'm saying this is the year we are going to get big returns from foliar fungicides. The amount of disease I'm seeing is of a magnitude much higher than we normally see. So in a normal year, this is the amount of disease we see. No fungicide required. This year, when we're seeing leaves being totally colonised and the leaf petals collapsing, this is the year where we're going to put our fungicides on. And I'm guessing rather than in the past, in a normal year when I'm saying 4 to 6 leaf, I've pushed this window out now and saying, look, if your crops are still vegetative, I think there's still a very good reason why you want to put a fungicide on and you would expect to get an economic return. Upper canopy management, again, things are very similar. We've got perfect conditions for blackleg, perfect conditions for plant growth, but now this perfect conditions for plant growth is actually probably working against us a little bit because it means our crops are elongating and coming into flower much earlier in the growing season than what we would expect. So, as I said, we want really to, if I just jump down to here, we want our plants to not really start flowering until middle August, ideally, from a disease perspective. So any plants which are flowering or commencing flowering between now and mid-August are going to be at risk of upper canopy. So things we need to know, look at the upper canopy blackleg ratings. If you've got effective major genes, if you are rated as an upper canopy, you won't need a fungicide. If you're anything below that this year, I think you will. The thing we don't know is what is the weather going to do in the next few weeks when the crops come into flower. So it may really dry up, and if that does, well, that's going to change things. If it stays wet as it is, this disease progression is just going to get worse. So the main thing I'm going to say to you is that if you've got quantitative resistance, you've got blackleg, we need to protect our flowers until mid-August, which is the same for Sclerotinia, which Kurt will talk about. So in that scenario, I'm really urging people not to jump in too early and spray their crops too early because you've got to remember you've got to get protection until mid-August. So in this scenario, if you're flowering early, I think we can hold off on our fungicides a little bit. We can let some of these early infections occur and then we can spray, we can kill those early infections and extend our protection out to get us to August. But if we can get protection to August, we're going to actually control the vast majority of the disease. And actually, before I do pass on to Ange, I'm also sorry, I'm jumping around here. I just want to make the point that I'm talking all doom and gloom and we've got to get our fungicides on and what, but the point is we've got good healthy crops, they're growing quickly, we've got good genetics, so we're not going to see a collapse, we're not going to see a destruction of the canola or anything like that. This is, in the worst case scenarios, I think getting that final 20% of the yield. There could still be very significant costly yield reductions from blackleg, but we're not looking at complete wipeout or failure, I don't think. And with that, I will hand on to Ange.
Cool. So I guess I'm just going to talk a little bit about how to make those fungicide decisions and keeping in mind that the higher the use of fungicides, the higher the risk of fungicide resistance. And as Steve said, we're constantly talking about not putting on fungicides. And then this year, here we are saying, get out there and put it on there. So I just wanted to give some information around how to make the best decisions on what fungicides should go on. So for the last 5 or so years, we've been screening for fungicide resistance using our implanter screen. And essentially what we've found is, with my slide will change. There we go. We have found resistance across the country to the DMIs, and so that's shown in these red boxes. And so essentially the red colour represents populations that have a high level of resistance to our DMIs. So this is quite high in Victoria, New South Wales, WA, and to a lesser extent in South Australia. And then last year and the year before, we did detect the resistance to the SDHIs on the Eyre Peninsula. So we had about 5% of the populations having resistance to the SDHIs. So when we are making these fungicide decisions, we need to then be considering that we already have resistance in some situations, and also about trying to reduce our risk as much as possible moving forward. So the things to keep in mind is that our DMI resistance is a tolerance, it is not a complete resistance. So what this means is that these actives still have some efficacy. They're not going to work as well as they should, but they will have some. So the actives that are affected are your prothioconazole, tebuconazole, flutriafol, and fluquinaconazole. And so how I like to think about it is it generally means that those fungicides are going to wear off quicker than they would normally. So say that they would normally last 4 weeks. If you've got resistance, they might only give you protection for 2 weeks. So that's a good way of thinking about what the effect of these DMI resistant isolates would do. In terms of the impact on the different actives, prothioconazole still works the best against this DMI resistance. Then your flutriafol, and then your tebuconazole and your fluquinaconazole have the least effect on these resistant isolates. The good news is that there is no cross-resistance to the new DMI active. So this is called Revysol in Revistar and Balea. And so if you are going out and considering putting on a fungicide for upper canopy infection, then the use of these new group 3 DMIs in regions where you've got DMI resistance would be a good option. For the SDHIs, the resistance is a complete resistance. So if you have SDHI resistance at a high enough level, you won't get any effect of those fungicides, and it affects all the group 7 actives. In some of the paddocks on the Eyre Peninsula, we have registered up to 90% of the population having resistance. So in those circumstances, you can put on as much as Moravis or whatever you want, and it's essentially putting water on your paddocks. It's not going to have any control over those isolates. For the QLIs, we haven't detected any resistance to those yet, so they are all still completely active in the Australian populations. So when selecting those fungicides, as Steve said, in a normal year, we would be saying don't put on a fungicide, but in 2026, we really do think a fungicide is going to pay for itself quite easily. Where possible, you want to rotate your actives to reduce that selection on fungicide resistance, and you want to avoid those back-to-back applications of the same active. As Steve mentioned, you want to consider your timing, so whether or not you're too late to put on a crown canker control strategy. So if you are moving out of that vegetative state, well, then you're too late to come in and look up control for crown canker, but then you don't want to come in too early for that upper canopy infection, because as Steve said, you need to be able to protect your crops for from now until August. So you then also need to be considering how long that protection is needed. So if you do need to protect from now until August and you've got resistance to your DMIs, then you shouldn't be using Prosaro for your upper canopy infection spray. You should definitely be looking at your Balea or your Revistar, which we don't have resistance to for the DMIs, and in the case of the Strobe, obviously we don't have resistance either, so that you get that longer protection to reduce any impact of upper canopy infection. Whilst the cheaper sprays have their place, I don't think this year and at this stage of the season that they are going to be a good option, especially where you've got resistance. So as much as it's going to be hard to necessarily convince growers to put on the more expensive spray, I think based on what Steve has just told you, this is the year where these fungicides need to be used, and they need to be used properly. And so spending that extra money on these products that you don't have resistance to is going to be worthwhile in the long run. All of the stuff that Steve spoke about, the Blackleg ratings for the crown canker, for upper canopy infection, that's all available in the Blackleg management guide and in the CM apps. You can also find in the apps strategies to help minimise your impact of disease, and also look at your returns of your fungicides if needed. Someone has just asked the question as whether resistance to aviator is also present. We do have some isolates that we've detected on the Eyre Peninsula that are resistant to both STHIs and the DMIs. And so in those circumstances, aviator won't work, but they were at an extremely low frequency. So at the moment, I do think aviator will still give you pretty good protection, even where you do have STHI resistance. And then the last slide I think I have, if it's going to change for me. Yep, it's just a plug for our disease updates that we're doing here on site not next week, the week after. This is going to be just a bit of an update of the seasonal outlook for the cereals, canola and pulses. It's going to also talk a little bit about viruses, and then we're going to be doing a tour of all the research that we're doing in the Blackleg space. So this will include our fungicide resistance work, all of our genetics and things like that. So if anyone's keen, jump on and sign up to participate in that. And that is all from us, Belinda.
Excellent. Thank you very much, Ange and Steve. We will keep on moving. Anyone who has any questions, please feel free to pop them into the Q&A box. I'm just checking that now, and I think we've answered the one question that came through. And as mentioned earlier, we'd worked to answer a lot of the questions that came through in the registration process. So thanks sincerely, team. And if there's any more questions, we'll ask them at the end. We now move on to our next session, which is looking at turnip yellow virus and green peach aphid. So I'm going to hand straight to Nicole, Maarten and Narelle for their session. Over to you, Nicole, to get us started. Thank you.
Perfect. Thanks, Belle. So yeah, as Belle said, we're going to do a bit of a tag team for us here. So we're going to start, I'll start off, and then I'll hand over to Maarten, and then Narelle will finish up our presentation. So I don't have slide control. Perfect. Thank you. So we don't really have a lot of turnip yellows virus recently in South Australia, at least, that has shown these sort of symptoms. So what we've in 2014, there was an outbreak of Beet Western Yellows virus, which some people may remember, and it causes this sort of purpling on the crops. Now, Beet Western Yellows virus is turnip yellows virus, so that's something to keep in mind. So the turnip yellows virus, the first thing that we noticed was early in the season. I was called out to have a look at a patch of forage canola, which had some symptoms, or had a lot of aphids on it. And then 2 weeks later, it was showing purpling symptoms, and we found, almost 100% infection of turnip yellows virus in that paddock. So subsequent to that, we have found turnip yellows virus very prevalent in South Australia, and I will come to the update later. So these are the sort of the typical symptoms that you see. In the larger picture there, you can see kind of a purplish sort of stretch there. This was taken up in the Clare Riverton area, and you can see an inset there of some of the symptoms that you see on the leaf. If you can go to the next slide, please. So when we're looking in the paddock for symptoms, so there is quite a range of symptoms when you're looking in canola. So you can see this is a slide that Narelle actually put together. It's a fantastic slide. It shows the difference that you can see on the leaves. But you do get this range of yellowing to purpling on the leaves, and it really is coming from the edge moving inwards. That's what we look for when we're trying to do a visual diagnostics of turnip yellows virus. You get this purpling and yellowing, but as with a lot of viruses, a lot of infection can actually be non-symptomatic, so that can be quite difficult to do a diagnostic in the field. And there's probably quite a few of you online that have been sending samples in for analysis with various members of the team to see if they actually are infected with turnip yellows virus. But you can see the bottom inset photograph there where they've got the really severe purpling. That's something that we see kind of if there's a really, really heavy infestation. We can move to the next slide. And I think I now hand over to Maarten for the next couple of slides.
Thank you, Nicole. Yeah, just a little bit of information from an entomologist. I'm an insect expert, so I'll try to explain a little bit how that transmission works. So this virus can only arrive through aphids, and the green peach aphid is the major vector that we know of in Australia. The virus actually is only in the vascular tissues of the plant, and it can only survive, multiply, and move through there. So that means that the aphid needs to penetrate into a plant that has the virus, feed on that plant, they only feed on the vascular tissues, take up the virus then circulates in the aphids will maintain infective all its life, and then the aphid has to travel from that diseased plant to a healthy plant, and that's of course where things go wrong. There's no other modes of transmission that we know of. Next slide, please. So if you think about how that then goes with your canola crop, you start with a healthy crop, you put the seeds in, it starts to grow, and then the question is, do the aphids arrive? And normally in South Australia over the last few years, it hasn't been the case. Aphids arrived in very small numbers and often very late in season. This year is completely different. Rain started in February this year, have been going on ever since. Plenty of green bridge, not just green bridge in your paddock, but green bridge in the landscape. And that's where aphids have developed. In that green bridge, there's plants that contain the virus. Aphids have been developing on those plants and then started moving because it was still warm, as Steve already explained, in Victoria, and same for South Australia. And if they land in your crop, they can transmit the virus to the plants. That's what we call the primary infection, coming from the outside into your crop. And that usually is low numbers. Unfortunately, this year it's not. It's large numbers coming in. And then in a normal year, you would probably have little transmission in your crop because it's getting late in the season, it's getting cold, aphids will not be moving, will not be multiplying much. And then in spring, you have a buildup of the population of aphids, and they can transmit from plant to plant, secondary infestation, inside the crop. But that usually happens only in spring. That's already quite late. So the plants, even if they get the disease, will not suffer too much and there will not be a yield penalty. This year, we think the big difference is that primary infestation, large numbers of aphids coming in. We don't know exactly where they came from, unfortunately. We're still working on that. And up to a level where crops have been completely infested with aphids in certain areas. It's very different according to where you are. So as an agronomist and a farmer, really do your observations to see if your population in the field is really very high and if all the plants are infested or not. 2026, primary infestation seemed high. We also saw quite a bit of issues with pesticide resistance. The normal seed treatments that everybody has always been applying have basically no good lasting effect anymore. And there's a lot of pesticides that green peach aphid is now resistant to. So the choice of pesticide has been really reduced. And unfortunately, that has surprised a lot of people that still have high numbers of aphids in their crop. And I think that's enough for me. And we go back to Nicole.
Thanks, Martin. So the epidemic this year, or how the virus spreads normally, it really is driven by those aphids. So what we look at when we look at management of turnip yellows virus is actually management of those aphid populations. So in previous years in South Australia, we haven't had really any aphids coming into crops early. So we haven't been really doing much in terms of active management of turnip yellows virus at all, because the infection has been so late that it actually has no effect on yield. So pretty similar to what Steve was talking about, you've got to really time your applications quite well in order to get effective control of those aphids. So the earlier that a crop is infected, the more the yield loss. Usually the growth stages of the plant, as Martin mentioned, in the last few years, what we've seen is that the aphid flights have not coincided with that early emergence of the leaves, either because of late planting or a late break or whatever else is driving it. So we haven't actually had that infection at that early stage. So what we have seen in previous years is infection right at flowering or beyond, where there is no really measurable yield loss there. But if you get infection early, this is where they have that really high risk. And so because it's driven by aphids, it's making sure you can see whether you've got green peach aphid on there in order to do that management effectively. We're currently kind of at that moderate infection stage, right? So for if you have not had any aphids or have not had any turnip yellows virus so far, if you're in the moderate to late, you're probably quite lucky at this time. So next slide, thanks. So what we've seen in 2026. So the first detection we had was down in the Padthaway border town area. So and then what we have had since then is reports of TuYV throughout the state. So the yellow dots on this nice map of South Australia is where we have had samples sent in, and thank you very much to all the agronomists who are sending in samples. We really appreciate it. It helps us a lot with the tracking of this. And so what we're doing is we are testing those samples of canola for turnip yellows virus. And so the yellow stars indicate where we have detected turnip yellows virus. The sort of the light blue stars indicate where we have samples and we have not detected turnip yellows virus. So we've pretty much found it everywhere except on the upper EP. We are looking for some samples from around the Kimber region. We've just got one sample from there, and that was from a roadside sort of volunteer canola. But we have done some more extensive surveillance around there, and we've so far found it in forage brassica, volunteer canola, weeds, and the new canola crops. We haven't tested a lot of the pulses because turnip yellows virus can also affect pulse crops such as lentils and have quite a severe yield effect. We haven't had any positive samples from there, but we also haven't received very many samples of that yet. So at the moment, the outbreak seems to be very severe this year throughout most of the growing areas in canola. Next slide, thank you. So yeah, as in terms of what we're doing now, as I said, like it's driven by the green peach aphid. So pretty much now, now that it's wet and cold, we don't expect the aphids to be moving very much anymore. And so what is infected is infected. I think that's pretty much the conclusion so far. But there is a gap between when a plant will become infected and when it will show symptoms. We can detect the virus several weeks before symptoms will appear. So we've been getting sent in samples that are clean and they have been coming back as positive. They're just asymptomatic until the virus it expresses the really obvious symptoms. So that foliar insecticide Maarten has talked about, but it really is an IDM strategy that we need to think about for turnip yellows virus and for other viruses as well to provide effective control. And I'll hand over to Narelle to finish off our presentation.
Thanks, Nicole. Okay, so hi everyone. So the virus situation in Victoria has been actually very similar to what Nicole and Maarten have described for South Australia, especially across Western Victoria, which is the region that I'm primarily going to focus on today. So during 2024 and 2025, across Western Victoria, the weather conditions were generally drier and warmer than average, and this for us also meant that the increases in aphid populations and the increase of turnip yellows virus incidence within the crops also occurred quite late in the season. And so this late infection, as Nicole explained earlier, generally would have had little impact on grain yield because it was so late and occurring so late in the season. But this didn't generally apply to all regions of Victoria. So for example, in last year, in 2025, there was a turnip yellows virus outbreak in canola in the early growth stages in the irrigated region of north central Victoria. So the conditions in that region, because it's an irrigated area, the conditions there were very different to the conditions that we were experiencing here in Western Victoria. And I think that highlighted really well the varying how turnip yellows virus epidemiology can change with and be influenced by some of those drivers such as irrigation and rainfall. So across Western Victoria this year, it's been similarly to South Australia, it's been a very different year for us. The rainfall events that happened in February, March led to early aphid infestations with green peach aphid, and they were flying at when canola was being sown, when it was germinating, and in those early growth stages. And although the presence of green peach aphid doesn't automatically mean that turnip yellows virus is present, the presence of green peach aphid, and especially at those early growth stages, really does increase the virus or the turnip yellows virus risk. And so having green peach aphid in canola in those early growth stages is concerning, because that's when the canola is most susceptible to turnip yellows virus infection, and also when the virus is also most likely to cause the most severe grain yield losses. So this year we've been monitoring the flying aphids at 3 different locations in Horsham using yellow sticky traps. Those traps so far have shown that that there were a lot of flying aphids around, so the populations increased quite quickly and quite significantly in mid-April. They stayed quite high and then decreased again quite quickly and quite significantly in late May, early June. And so at the moment, we're not really seeing any or very many aphids at all on those traps at those locations. We also started receiving reports of green peach aphid in canola, and we started receiving canola samples for virus testing through CropSafe in late April, early May, and we're still receiving canola samples for turnip yellows virus testing now. So I think given the time of year that we're at, and as everyone has said, we're moving into the early flowering stage of canola, or some crops are probably already there. I think the most important management strategies at the moment are reminders. So one is that, as we've all been pointing out here today, that canola is most susceptible to turnip yellows virus infection and more severe yield losses in the early growth stages. And research has shown that turnip yellows virus infection from flowering onwards typically has little impact on grain yield in canola. So I think it's really important to be keeping that in mind from this stage going forward. It's also, I think, a good thing to keep in mind that the impacts of turnip yellows virus infection can be worse when plants are stressed. So when they're stressed by factors such as drought, waterlogging, and nutrition deficiencies. So this table here, it shows is a table of contacts really. So across Victoria, New South Wales and South Australia for turnip yellows virus testing, assistance with aphid identification, and also for aphid insecticide resistance testing. I believe that this table will be sent out to everyone in a follow-up email after the session has finished. So that will come out to everyone. Oops, I think I might have just gone one to, nope, that's okay. And just to finish up, I'm sure that most of you already have these documents, but just in case, I wanted to mention and recommend the recently updated GRDC turnip yellows virus fact sheet that's titled Manage Turnip Yellows Virus in Canola, and also the Green Peach Aphid Best Management Practice Guides. These documents have some really great and important information about managing green peach aphid and turnip yellows virus in Australia in canola, and they're really important resources to have. And again, the links for these guides will be included, I think, in Belinda just put them in the chat, but they'll also be included in the follow-up email that's sent out later on today after the session. So I think that's me. Thank you very much, everyone.
Beautiful. Thank you very much. We're starting to see some great questions come through the chat. So speakers, can I ask that you start to have a look at them? We will go live to questions in a moment, but first I thought we would throw straight to Dr. Kurt Lindbeck for an update on what's happening with Sclerotinia, and then we'll come back to Narelle, Maarten, Nicole, Steve, and Ange for some more questions. So heading on over to Kurt, what's happening on the Sclerotinia front? Thanks.
Oh, geez, unfortunately, plenty, Belinda. And I suppose to some degree, I'm going to echo what Steve was saying earlier on in the presentations, is that we seem to be having more or less the perfect storm, that combination of early development of crops, excellent growing conditions, but also a lot of frequent rainfall events. And I suppose I'm going to be referring a lot to southern and central and southern New South Wales, but also northern Victoria as well, where we do tend to see pretty frequent outbreaks of Sclerotinia. And so what makes this season, I suppose, a little bit more risky compared to previous seasons is that, yes, we've definitely got the development of crops running probably 3 or 4 weeks ahead of where we normally would be. And the other thing to remember is that certainly in our part of the world, in the last probably 10 days, is we've seen conditions where the soil has been saturated for fairly extended periods. And so what that does is that softens the sclerotia in our soils and really primes them up and gets them ready to start to develop apothecia, the little fruiting structures for the Sclerotinia fungus. And just in the last week, I've actually received a couple of reports where apothecia have already been observed in some crops in the southern New South Wales region. So we know that the fungus is active. And so, of course, Sclerotinia being a little bit more complicated compared to other diseases, it's basically a 3-stage disease. So already we're seeing the first box ticked, the sclerotia are primed, they're basically producing the apothecia, and we'll be starting to release the ascospores. The second part of that, of course, is the ascospores being intercepted by canola petals as soon as they start to emerge, and sufficient moisture then for those ascospores then to colonize that petal. And then the third part of the puzzle, of course, the third duct to align, is then those petals, which are becoming colonized, falling down into a wet crop canopy. And so really we're starting to already see the first 2 ducts in our line basically being met. And then time will tell in the next few weeks whether or not we then see the final stage, and I suppose the most damaging phase of the disease, with the transfer of that infection then from petals down into the crop canopy. And the problem is that given we are the first week of July, we still have a long way, a fair bit of winter to go, and that we know, July and August, I know in southern New South Wales, are traditionally our wettest months, which we know places us at a reasonable risk of a lot of Sclerotinia infection this season if we're not careful. Did you want to talk about fungicides at all, Belinda, or how far?
I think so. Give us some insights. That would be great.
Yep, absolutely. So again, I suppose echoing what Steve was just saying before, it's important not to pull the trigger too early and not to place too much emphasis on the movement of fungicides through crops. So really, just remember our foliar fungicides are best used as protectants, and that those newer products with some systemic activity, that's a bonus. And so really the optimal timing for these products for Sclerotinia management and upper canopy is 20 to 30% bloom, which Steve has already spoken about. That's 15 to 20 open flowers off the main stem. So just remember, I'm talking about bloom stage here, not flowering. 20% flowering is 20% of the plants within the crop having a flower. So by the time you get into 20 to 30% bloom, that's 10 to 14 days after the commencement of flowering, and there'll be a reasonable amount of yellow across the paddock when you look at it. But the main thing is that generally around that 20 to 30% bloom, that's where we start to see the first significant shedding or senescence of petals down into the crop canopy, which can basically trigger those stem infections. But the crop canopy is also pretty open, also very open. So if you come in with a foliar fungicide at that growth stage, certainly with a ground rig, you're going to get really nice penetration, and penetration right down to ground level with that product, especially if you're using high water rates and finer droplet sizes. It's all about coverage and getting fungicide product down onto those lower leaves and stems. So potentially, if those infected petals fall down into the crop canopy later in the season, they will be protected from spreading that infection. And I suppose the other note on that is that just being aware of the different periods of protection offered by each of the fungicide products is different, and they do vary. But as far as the number of products available, they have never been greater. There are so many different combinations, and the list of registered products out there is certainly grown in the last few years, of both licensed products, but also products now that are coming off patent. So yeah, best of luck, and we'll see what the season brings in the next few weeks. I think it'll be pretty important.
Perfect. Thank you very much for that update, and we'll get you to stay online with your camera on and your sound on in case we have any more questions. We are almost at the end of our scheduled webinar time. However, there's been some great questions come through for the chat. So I think from our speakers, we're happy to stick around for an extra 15 minutes and get them answered for you. So we might work through them. If you do have to leave at 11 o'clock, we will send the pre-record around so you can get the answers to the question later. Bridget will be sending around a post-webinar MailChimp, which will have links and answers to your questions in as well. But for now, I'm going to open up the Q&A, and I'll start with one that's come through from Matt. Thanks, Matt. What are the expected yield losses from the virus in a healthy, actively grown crop when the aphids were removed early? Aphid infection population was 1 to 2 aphids per plant in 2 to 4 leaf canola when sprayed. Anyone able to take that one for me, please? Nicole, maybe for you.
I would have to look at the fact sheet to have a quick look at that. The fact sheet does have some good information about the yield losses, Matt. So maybe have a quick look at that. It will depend. There is quite a few factors that we didn't talk about today in terms of the yield losses. There are different strains of turnip yellows virus. Now, what we've done some strain testing in South Australia, and we found strain 1, which is a severe strain, but there are 2 other strains of turnip yellows virus as well, which are less severe, so they would have less yield loss. I don't know what strain you might have. And then you also have, there is some genetic resistance in our germplasm as well, resistance and tolerance, which we don't really have effective ratings for yet, but that is part of our research project. And Ben Congdon is actually working on that, and he's out of DPIRD WA, so he's got some work going on in that. So it is quite a hard question to answer, but the younger the crops when they are infected with the virus, the more yield loss you are expecting. But I'll let Maarten, he's got his hand up, he'll probably contradict me.
No, I'm not going to contradict you. I'm just going to give you a little element which is important. I mean, this is canola. Canola is a plant that is very well able to adapt to some plants not producing. The seeding density is usually quite high, and you'll get the same yields potentially whether you got 10 or 35 plants per square meter. So I wouldn't be too worried about a low percentage of plants having the virus very early dropping out in their contribution to growth and yield, because the healthy plants will take over. It becomes critical when there's a lot of the plants infested very early. Unfortunately, we don't have the data in most cases. We can see a few plants with symptoms. We don't know exactly how all the other plants are, whether they are infested or not. So yeah, it's really difficult to predict effective yield loss in canola, and usually it's not as bad as you initially think.
Thank you. Oh, yeah, far away.
Sorry, can I just say as well that like I mentioned earlier, the weather conditions can also impact the extent of the yield losses as well. So we often see more yield losses in really dry years, when the plants are stressed, or if they're waterlogged as well. So at either end of the scale, the yield losses can often be a bit more, depending on the growing conditions as well.
Can I just add that we've had I was talking to an agronomist a couple of days ago, and a very severely affected crop that he was looking at, they reckon they've had about 10% of the plants now like just dead, and everything else is going on. So and it looks that it's, you know, currently looking not too bad. So, you know, even those very severely affected ones, it's very hard to tell what's going to happen after the during the season, depending on what's going to happen with the weather.
Thank you. On while we're talking about the virus, a question has come through with regards to insecticide resistance. Is there anything we need to consider there?
I can take that one. Yes, this is green peach aphid. Green peach aphid is resistant, has shown resistance to a lot of the insecticides that are on the market. It has shown this year very clearly that most of the seed treatments are not very efficient anymore. So at the moment, basically, we have 2 pesticides that seem to have shown very little or no resistance, which are aphidopyropan, which is sold under the name Versus, and flunicamid, which is sold under the names Mainman and Aria. Those 2 pesticides seem to be still working fine. Not the cheapest, but the big advantage is that they are also quite respectful of beneficial insects. So Foxaflor, so Transform, clearly shows a buildup of resistance. If a farmer wants to use that, certainly go for the higher dose, even though it's more expensive, because there's too much risk of resistance at lower doses.
Excellent, thank you. The other question came from one of the chats, and it is, could you please explain interaction between the 2 diseases? And then the second part to the question is, and the impact of nutrition on disease severity, please.
So
sounds like a fun one for Steve, I reckon.
Yep, go ahead, Steve.
Okay, I'm assuming when we're talking about 2 diseases, we're talking about Sclerotinia and Blackleg.
Just says interaction of the 2 diseases.
All right, I'll go with that's the case. The great thing for upper canopy and Sclerotinia is that the timing for the fungicides and the critical infection periods are very, very similar. So the same infection events which are causing Sclerotinia outbreaks are going to be the ones that are causing upper canopy blackleg as well. So we can really manage them together, I think. Whether one makes the other worse, I don't think we've got any data to suggest that. I don't know if you've got anything like that, Kurt, but I think the reality is that if you're flowering early and you've got rainfall events, both diseases are going to take advantage of it.
Okay, thank you. Any other comments from around the team?
I guess in terms of viruses and their effect, like I definitely saw a crop which had lovely emerging blackleg and lots of virus. I think if you've got a plant that's a bit sick, it's going to pick up lots of anything else that happens to be around there. And it's going to be one of those years, unfortunately.
The minor comment.
Sorry, go Kurt.
Yep, and I was going to say, Steve, just quickly, the minor comment is at the end of the season, certainly branch infection with upper canopy and branch infection with Sclerotinia can sometimes be confused. But in some instances, upper canopy infection can actually take out a single branch or a portion of a stem and leave a bleached dead section on the stem that actually looks a lot like Sclerotinia. And we saw that quite widespread around Wagga 2 years ago. And the main diagnostic feature there is to actually cut the stem open, and if the internal pith is either black or very dark grey, it's blackleg. And if it's still white, well, then it'll be Sclerotinia. So it's pretty important not to get the 2 confused, because there's implications and down the track with regards to the return of sclerotes to the soil and future disease outbreaks.
I guess in terms of viruses, a lot of virus symptoms look like nutrient deficiency as well. So in terms of, you've kind of got to know what your beast is. in order to effectively to put any management on there. So the nutrient deficiency definitely is an issue, and I think that's why we are getting a lot of samples sent in, because, you know, what doesn't turn canola purple is a bit of the question sometimes, especially if you're not used to seeing it out there. So it's getting that correct diagnosis and might give you a leg up in able to do some effective management.
Thank you. Another one that's come through on the virus, sorry. Can there be yield losses from turnip yellows in crops with low levels under 5% of obvious symptoms this week in crops that appear healthy, or does the level of symptoms equate to yield loss?
Another very tricky question. Pretty similar answer to what we were talking about before that, with Narelle and Maarten. Like, it does depend when the virus got in, when the aphid flights were, and then how tolerant that variety is. Symptom expression comes several weeks after the aphids have flown. So you won't get symptom expression immediately. You know, if you see aphids on there, you won't get symptoms until probably 4, 6, 8 weeks after you've seen those GPA on there. So the expression of the symptoms is really dependent on the plant stage and how much you get there. So I was partially writing the answer to that question because it's a bit of a tricky one. There's a lot of factors that sort of sit in there, but the fact sheet actually has quite a lot of information around that. So I'd recommend having a good look through that.
Okay, no worries. There's just one more for you, and that is the virus has now presented quite drastically in paddocks we were monitoring and only finding very low aphid numbers. What do you recommend there, as you do not know if the aphids carry the virus or not?
So what we've seen, I mean, with the extent of the outbreak that we've seen so far, in SA, and Narelle can jump in because they've got some more monitoring data from them. We've been able to detect the aphids with the virus when there are no symptoms in the field in previous years. So we know that the aphids are carrying the virus. But we don't know, you're right, we do not know the extent of it in a particular area all the time. So it is a difficult. Oh, Maarten, do you want to jump in?
Well, just as additional information, I mean, it is getting into winter. It is getting cold. Aphids will not be much on the move. So I would be very reluctant to spray now against aphids. I would certainly wait and see how the population evolves over time. And only once it gets warmer again, there is a risk of transmission to new plants in the crop. So yeah, I would not be too worried about what you see now. And if you see symptoms and if the plants are already diseased, that's something you can never solve with a spray. It's only that secondary infestation, which will probably happen only when it gets warmer in spring. That is an issue. I would hold on using too much pesticides.
You can also have a look at the pattern of the infection. It's what we use in field virology, the pattern of the infection or the symptoms that you see. Is it a blanket going across the paddock? Is it coming in from the edge, or is it a foci in the middle? So if it's a foci, like a circle in the middle of your crop that's going out, that's kind of that secondary infection that Maarten was talking about. And if it's more a blanket approach or coming in from the edges, that's where you've got those flying aphids coming in, where you're getting primary infection. So it's worth having a look at the spatial distribution of the symptoms in your paddock. It can give you a bit of an idea about what stage the virus is spreading in that plant as well, in the paddock as well.
And there's a nice table in the turnip yellows virus fact sheet as well that can help with some of those decisions too, that takes a few different factors into consideration. So yeah, I think that's a really good resource to be using to help make those decisions as well.
The fact sheet was only just updated in February, so it is the most timely fact sheet known to man.
Excellent.
It's very
Thank
useful.
you. And Bridget's put a link to those fact sheets into the chat. All right, team, I think, just one more question's popped in. For you, Steve, how many weeks would you expect, Steve, in the current conditions? I don't have any
going on
context to that
holidays.
one.
Is the answer to that? No. Look, the rain we've seen this week is going to result in many more lesions coming out in the next 10 to 14 days. So over the next few weeks, we're going to see a lot more disease turning up. And then it's an infection cycle. So after that, it'll be dependent on more rainfall. So if this super El Nino does come true and we suddenly get massive highs, the disease will pull up very quickly. But all the disease we've seen so far is all going to go systemic and start causing crown cankers or upper canopy if the crops are already flowering. So there's a good chance that if it does go really dry, we may not need as much upper canopy sprays in 2 or 3 weeks' time.
Thanks, Steve. Another one's popped into the chat and it says there's some use of beneficial insects in smaller cropping such as strawberries. Is there any movement in this space for broadacre, or is the scale just too large to make it work and timing too hard to nail it for effective control?
That's mine, I think. Insects, controlling insects. This year is really spectacular as far as aphids, but generally speaking, all pest insects, and as we've heard also about diseases. Beneficials will come in and will be able to reduce the pressure, but they normally do that only in spring. We've seen more beneficials, but we've seen a lot more pest insects. So I'm a little bit reluctant in saying that you can be confident that beneficials will control your pest at this stage. They will certainly contribute, but I would certainly be monitoring very clearly in the crop to see what's happening with the populations. Like I said, some of the pesticides that are still working against green peach aphid are actually quite respective of the beneficials. So another good reason to choose these. If you think about using beneficials in the sense of releasing, that's still in a very experimental stage. I don't think we can promote that at this stage simply because there is not enough production of beneficials for grains, large-scale cropping situations. So I think we're not ready for that, and our current GRDC investments, canola alleys, will contribute to that, and I hope that I can be a bit more affirmative in the role of beneficials in a couple of years.
Perfect. Thank you very much. Well, team, we've worked our way through the questions that have come through from the chat. They've been either answered live or our speakers have written directly back and we've shared these into the chat. So hopefully you've come along, had your questions answered. If you have any more questions, we do welcome them. We are here, we are really agile with how we can turn around and get content out to you. So if you have any other information needs, please reach out to us. On behalf of the whole Disease Management Extension Network team and GRDC, thank you for joining us today. We'll send some further resources out, but we do invite you to keep in touch with us. If there is information that you need, please let us know and we'll work to get that to you as quickly as we can. I just would like to say a big thank you to our speakers today, Ange, Steve, Nicole, Maarten and Narelle, as well as Kurt for joining us on Sclerotinia. We really appreciate your time and insights, and we'll continue to monitor the season, and we can put on an additional webinar should you feel like we need it down the track. But thank you all for joining us today. We really appreciated your time. And friendly reminder, we do have our disease management extension team referenced up there. A reminder that this information is to help you and to seek your own advice to inform decisions relevant to your business. So from here, we're wishing you all the best for a successful season.